All right, welcome everybody to the September 14th Portland Amateur Radio Club meeting. This is kind of a special meeting because we have a couple of presenters for our main presentation who are from England. And so the reason that we're doing this at 11 o'clock in the morning instead of our usual 7:30 at night is because I couldn't talk Graham and Alan into starting the presentation at 3 a.m. their time. Which is fine. We're actually going to be recording this presentation and we'll post it later to YouTube. So anybody that missed it or anybody that would like to review this this meeting, feel free to go back. We also have the slides and we also have a video that Alan did earlier this year on this particular antenna build. So welcome everybody. Everybody that joined, you are joining as muted. Feel free to unmute yourself at any time. If you're on a PC, usually that means you can press your space bar or there's an unmute button. And then if you can, if you're not actively asking a question or making a comment, if you could just mute yourself again so that we can cut down on the noise. So welcome everybody. Just to kind of start out, this meeting probably will run a little bit longer than normal. And I have gotten the okay from both Graham and Alan. If you guys need to leave during the presentation and join back again later, that is perfectly fine. Again, we're recording this, so anything that you missed, you'll be able to catch up on either later today or in the future. So one of the first things that we do for all of our meetings is we introduce anybody that is a first-time Portland Amateur Radio Club meeting participant. And I recognize the vast majority of people on here, but is there anybody that this is their first time joining Portland Amateur Radio Club meeting? Go ahead and unmute yourself.
Hi there, this is Bob, N8SQT.
Hi, Bob. And what we actually have you do is, let me just fast forward through here. Just let us know what your name is, and thanks, Bob. Your call sign if you have one, looks like you do. And then how did you hear about Portland Amateur Radio Club, and then what kind of interests you in ham radio in general?
Oh gosh, I've been a ham since 1992. Got my extra about 3 years ago, I think. Yeah, I just been into it for a long time. I got interested in it when a buddy of mine back in Ohio was doing phone patch calls on the repeater. So that was kind of, that's what got me into it. So anyway, yeah, but as far as how I heard about PARC was just doing searches for clubs in the area when I came out here to Oregon.
Very nice. Well, welcome.
Thank you.
And anybody else new or this is their first time?
Yeah, hi, this is Mark, first time, K7MRT. I've heard about PARC just from looking online and finding a local Portland group. I live in Tigard. And what brought me to ham radio is that my daughter was getting licensed down in rural Bend in Oregon. And she did not want to be licensed, but her husband almost insisted because she commutes to Coos Bay and cell phone coverage down there just doesn't work. So if she had an emergency, she had no way of contacting him. So because she went through it, I went through it, and my first contact was a surprise contact to her. She was my first contact. So that was
cool. Oh, that's awesome. And then also, Mark, did you take your test online?
No, I've been a ham about 8 years, so I was
okay.
Look at the old-fashioned way.
Okay, great. Yeah, we're doing some online testing now. That I don't know of anybody that's actually doing in-person testing, but we will have a presentation in the future, probably next year, from one of the very active people here, Herb, that has been doing a lot of online testing. Very good. Well, thank you. Anybody else? Is this your first time? All right. Hearing none. Go ahead.
This is Bob. I W7JNM. This is the first time I've been on a PARC meeting since I changed my call sign. Been quite a while. I heard about you guys through Aries, Multnomah County Aries.
Yeah,
And,
absolutely.
just wanted to say hi, and I'm also a VE for Herb.
Oh, that's great.
Yeah, look forward to his presentation. Thank you.
Absolutely. All right, and I think we got everybody. Anybody else? This is their first time? All right, so I'll go ahead and go over the agenda. So we'll have some announcements and news. I don't actually have I don't have a lot of announcements or news, but if you guys have something that you'd like to let the group know, please feel free. Our main presentation is going to be building and testing your own magnetic loop antenna. This will be a great presentation. This was a couple of guys that Dan Presley actually turned us on to. And we took us a few months to kind of organize everything, but both Graham and Alan are over in the UK right now. It's great that we have Zoom to be able to connect everybody. And then we'll have some member questions and comments afterwards. So for news, one thing, I don't think that we're going to be having a live repeater broadcast for this meeting. I do see a phone number on, and I'm going to check with Pete. So Pete and John White are the two people that handle the repeater simulcast or broadcast of the live audio. And Pete, are you on now?
Yes. Are you able to hear me?
Yeah. So is that the repeater that's on?
Well, I don't know. I have not heard from John. I did send you an email about 20 minutes ago.
Okay.
But as far as I know, we'll have to broadcast it later on the repeater.
Okay. No, that sounds good. And if you do get any updates, just feel free to break in at any time.
Yes.
Okay.
Thank you.
Yeah, absolutely. And then the other thing that is kind of new that's been circulating is a proposed $50 amateur license fee. This hasn't taken effect yet, and comments actually have not closed for this. Jeremiah, did you want to talk a little bit about this?
I was going to, but with everything going on, I didn't get a chance to do the amount of research that I needed to speak authoritatively on the subject. I think it's probably better left in more experienced hands that have been around a lot longer than I.
Yeah, that's no problem. And I don't know that much about it. I did a little bit of research on it. Essentially, this is a new proposal by the FCC, and they're proposing $50 fees for new licensees and I believe renewals, although not any, nothing is set in stone. So I know some people have opinions one way or the other on this, but we'll have more information about this during our next meeting. The comments are live, and I don't have any slides to share with you on how to get to the comments, but the ARRL has already written a very short article, and at the bottom of the article, there's a link that will direct you on how to get to the comment section. If you want to comment on this proposal, I highly encourage all hams to do so. Don't feel like you're going to get left out if you don't do any comments in the next few weeks. We'll remind you again during the next meeting. And anybody else have any other news or announcements for the good of the order?
Yeah, I just want to wish Dan Presley a happy birthday today.
Oh, thank you. Yeah, happy birthday, Dan.
Thanks. This is a fun presentation. And although this weekend I was hoping to get outside and get a little more activity in outdoors. But speaking of that, this coming Saturday is yet another QRP CW outdoor event, and it's called QRP A Field. And that's happening Saturday from 8 a.m. to 3 p.m. Kind of hard to tell where it might be safe to go outdoors. It might be in the backyard assuming that the smoke clears up. But this is one that's gone on for quite a few years and gets a lot of participation. So if you're interested in that, you can just go online and search for QRP a field. And thanks. And yep, older, but still here.
And Dan, do you have to be like in a special place, like in a public place, or is it just anywhere outdoors?
No, anywhere outdoors. I mean, you can operate from home too. You just, get extra points if you're outside. And to me, that's always fun, to take the radio outside and have some fun with it. Speaking of that, Jeremiah and I did a little quick outing last Monday. And originally we were going to go up to Mount Hebo to do a soda outing, activate Mount Hebo. But checking the weather forecast, that's when the winds were starting. So we redirected and went to Cooper Mountain, which is out in Beaverton. And Jeremiah got to use his infit. In fact, at some point, I think, if not today, perhaps at a future meeting, it would be fun to have him talk a little bit about his infit half-wave.
Yeah, that's great. I know that I saw his very miniature NFED half-wave, and it looks like a very simple project that just about anybody can do. So yeah, so at a future meeting, if you're willing, Jeremiah.
Yeah, absolutely. If my thumbs can do it, anybody can.
Cool. And then Bill, you had an update on public land closures?
Yeah, thanks, Max.
Yeah.
I'm a volunteer both for Portland Net and Red Cross, and I want to encourage people before you plan an outdoor event, check NWCC, the Northwest Integrated Command Center, because at this point, all of the public lands in the state of Oregon and much of Washington are closed. BLM lands, state parks, and national forests. Some are still open, but they're subject to immediate closure. It's a combination of, frankly, everybody's working on the fires, and two, the fires are moving quickly enough that the Forest Service and BLM, don't want to start running search and rescue missions for folks. So if you're going to be outside, which is probably not a great idea given the smoke conditions, please check ahead to be sure where you're going and the roads to and from it are not under a closure order.
No, that's good advice, because I have heard that there's a lot of places that are closed, public places. So, and if you're going out to the public areas, the key word is to be safe, especially with all the smoke and the fact that we have very bad air pollution right now. Thank you for that. Anybody else announcements that they'd like to make?
I have a tidbit. This is Denny.
Hey, Denny, go ahead.
I know it's quite a bit in the future, but Salem Repeater Association announces the Salem Ham Fair in February 2021 will be canceled. Wait till next year. It's because of the virus. And so it was the first ham fair of the year, first and the biggest in the Northwest every year. It's canceled, and we'll see what happens next year. Thank you.
Thanks, Denny. And Bill, going back to you for just a second, you mentioned the NWCC.
Yeah.
Can you tell us what that is again?
Yeah, hold on. Let me bring the website up so I make sure I give you the right URL.
Yeah, and if you could put that in the chat, that would be great.
Okay, great. Yeah, we'll do that.
Okay.
It's the Northwest Interagency Coordination Center, and it has the lead website. There you go. Steve has got it. Actually, here's the direct fire info page. So there's a base fire map there, but there's also information on individual fires and road closures. And there are hooks into the BLM announcements. If you look on the front page, you'll see a list of all the current fires. And then within those those announcements are lists of closures and links to closures. And as I said, at this point, all of the BLM lands in the state of Oregon, all the national parks in the state of Oregon, most of the national forests in the state of Oregon are all under closure orders. And they're treating those areas generally as level 3 evacuation areas. So if you get stuck out there, there's probably no one that's going to be available to come and help you.
Yeah, that's a very good point, Bill. Thank you very much for that information.
Yep.
Cool. Anybody else? News or announcements? Very good. So for those of you who are outside of the Portland area or outside the Oregon area, we've had some very bad smoke and wildfires here. So it is clearing, it looks like, a little bit today. I went outside and didn't immediately choke, so that's always a good sign. Hopefully tonight, maybe tomorrow, we'll get some rain and it'll eventually clear out. All right, so one quick announcement. If you'd like to be either a future Portland Amateur Radio Club guest speaker on a particular topic that you enjoy, please feel free to contact me. My email is down there, k2max@arrl.net. Or if you have any suggestions. So far what I've been doing is kind of bouncing ideas off of Dan and Nick and some other people in the group about interesting topics, interesting presenters that we'd like to have. And I want to thank, all the people who have volunteered their time and effort into putting together presentations and giving them to our club. They are unpaid, and so I just owe a big thanks to them. But if you have either presenters that you've heard in the past or topics that you would like to have covered in the future, please let me know. All right, and I see Alan has made it on.
Yeah,
so,
finally, I managed to get my system to reboot into Linux because
that's awesome.
Like the camera didn't seem to like Windows, and I don't like Windows anyway.
Awesome.
I managed to get it to boot in, so hopefully we'll be ready to go in just a few seconds.
Yes. So let me pull up. So there's a slide you can see, I think, hopefully on the screen. Our main presentation today is going to be building and testing your own magnetic loop antenna. Hopefully, if you're like me, I wanted to have a lightweight antenna that I could either take out to the field or use in my front yard. And I've known about magnetic loop antennas for quite some time. However, there is a lot of information on the internet on how to build them. But after spending hours and hours reading the information, I've kind of come to the conclusion that it's above my ability to actually create one. That was before I talked to Alan and Graham. Alan is a retired engineer. He spent his career on HF and VHF, point-to-point radio communications, and he was project managing data centers and other electronics projects. And Alan is going to give the main presentation today on building and testing your own magnetic loop antenna using a lot of available parts that are pretty inexpensive, and he has a lot of data to share. And Graham King, KGXSD, started in radio engineering, and he transferred to academics. He retired his career from the UK university, and he was running a research center with 30 PhD students, and they were researching and testing, mostly electronic and computing, producing designs for parallel processing. And Alan and Graham both belong to the Itchen Valley Amateur Radio Club, and you can see their website is down there on the slide, ivarc.org.uk. So without further ado, Alan, I'm going to stop sharing my screen, and then I will go ahead and let you share just as soon as I find the stop button. There it is.
Firstly, can you hear me? Can you see me at your end at the moment?
Yeah.
Okay. So I'll start sharing my, it just says host disabled.
Yes, give me just a second.
I'll just have to bring it up into slide mode. Then
There you go.
hopefully, fingers crossed, it'll all work. Wait, I don't want to show, I think I've got to get this right. Oh, that one. Share that. Okay, let's go to slide mode, slideshow. Start from first slide. Well, a very good morning to everybody, and obviously good evening to anybody who's not in the Pacific area, or good afternoon, depending which part of the world you're actually listening from. I'm Alan Badcock, Jed IPQ, and I'm a member of the Itchen Valley Radio Club UK. And the first thing I'd like to say is a very good greetings from our club to your club, and we hope you're weathering all the difficulties that seem to be on us all around the world and in your locale as well. Hopefully this talk will cheer things up a bit and give you some practical ideas to go away and do things with. The problem with magnetic loops is there's lots of good information out there. There's some very good gurus around the world, but there's also a lot of rubbish talked as well. And you can do things simply or you can make it hard. My view is to do it simply and cheaply and get going. The secret is to get going. So with that, I'm going to hopefully go on to the first slide. So the aims of this talk are to illustrate the practical construction of a multiband HF magnetic loop using available parts. You know, we don't have anything esoteric, expensive that you might not get at a boot sale. Although any aerial you can make and you can perfect it and go for lowest this and high tune that, you'll never get anything going unless you start. The problem with magnetic loops, it's a little bit different from the usual things we're with, and the aim of this talk is to get you started. So I'm going to outline some rules of thumb to start to design your own loop. I'm going to discuss some construction and operating issues. I'm going to present some initial field test results versus a short end-fed vertical. And I will demonstrate, I've got a little video, very kindly filmed by my son on his mobile. So the quality isn't up at professional level, but it'll make the point. And then to explain the testing methodology. Now, you've got a real bonus. You've got a real whiz in some of this area, and he's the guru for our club, and that's Graham, G3 XSD. And building on, at the end of this talk, he's going to take a section on how we did the testing. And the big thing about this is that the same methodology could be used to test all sorts of aerials in amateur situations without using huge amounts of expensive test gear and get a very reasonable result. But I'll leave all that excitement for Graham's section. Okay, what's a magnetic loop? Well, a vertical loop antenna that has a circumference, forget diameters and all this sort of thing and how big the loop is at the moment, which has a circumference that lies between lambda over 10 and lambda over 8, the wavelength of the particular band you're interested in. If it is bigger than lambda over 8, if it's within that or less, it'll radiate a magnetic field, as against the dipole that tends to radiate an electric field. Obviously, both electric and magnetic fields have got to be present to satisfy the Maxwell equations, but it's where the launch happens. And with a loop, it's in effect a solenoid, or a single turn solenoid, or a multi-turn solenoid. And we'll be coming to that in a minute. But in order to get it to launch magnetically, so that the magnetic component is what actually launches, you need to be between lambda over 10, lambda over 8, or you can go a bit less than lambda over 10. But as you get smaller, the efficiency goes down. As you get closer to lambda over 4, you're starting to get closer to an electric resonance. like a conventional wire loop aerial. So how do you bring this loop, this circle, into resonance? Well, you bring it to resonance with capacitive tuning, and it forms a resonant tune circuit. This loop will have vertical polarization, and it will radiate at both high and low angles along the plane of the loop. Now that's brilliant because you've got low angle radiation, you've got high angle radiation. It's basically, if you think of a dipole turned round in a loop, the donut, you're forming a donut vertically like a rubber tire, and therefore the radiation is at all sorts of angles. So it's incredibly useful for a number of different things. It exhibits a null in the axis of the loop, and that's very useful. It's not too deep a null. It depends how well the thing's made and how big it is, and a number of factors. But it can be useful for pointing towards a source of electrical interference, or giving some sort of basic directionality. And I know that people have made use of that fact in different ways. And the big thing, especially for people in small gardens, I only have a small garden. My garden's 80 feet long by about 50 feet wide. Not great for huge aerials, and certainly not getting masts up. You can mount it just above ground with a simple support, like on a tripod. But you've got to minimize the ground losses. You have to ensure at least one loop diameter above ground. So it's not really difficult. And it's practical for apartment balconies or rooftops and that type of thing. So it's got great flexibility. Bung it in the back of the car, take it out to a park or something, and it gives you another type of aerial. Okay, let's go to the next one. I've got to remember, I've got to manually flip this now. What are the advantages of a magnetic loop? Well, it's compact size, it has simple mounting arrangements, and it has low visibility impact, which is of course great if you're in a densely housed area and if there are any restrictions. Our planning rules is that you have to get planning permission to go more than 2 meters above the apex of your roof. So it tends to limit you for what you can do unless you put a very good case forward. It rejects electrical noise interference, and I have seen that it improves over a monopole by about 2 to 3 S points. And on my roof, and that's important because I put the null towards my house, on my roof I have a 4 kilowatt solar array, which is a bit noisy at times, especially in the sunshine when I'm sitting on the back patio. Has vertical polarization, radiates at high and low angles along the plane of the loop, and it's good therefore for NVIS and for DX. It exhibits a null in the axis of the loop, can be used to reduce the impact of an electrical interference source. It has a very narrow band at resonance, so it can reduce strong signal interference, and it's very good for that. The downside of that, of course, it's a very touchy on the tuning. It's very, very, very precise tuning. You can construct it for a single band, which of course gives you the best results because you can optimize it for that band, or multi-band. Normally an octave, but you could probably cover 2. Now, you normally would do sort of 80-40 or 40-20 or 20 or 20-10, that type of usage. But the one I'm going to show you now, it will actually cover 2 octaves with a bit of capacitive switching, and it's using a 2-turn loop. Okay, I keep remembering I've got to, there we go. What are the disadvantages? Well, it has to be retuned at frequency change, as it has a very narrow bandwidth at resonance. Large reduction drive is needed for a precise tuning, and you need at least a 10-to-1 reduction drive, because if you think of a 10-to-1 drive, if you're using a split stator, that's really only 5-to-1, and if you're using a butterfly, that goes down to 2.5-to-1. So you want as much as you can. My early experiments, I was lucky I had a 200-to-1, which was good for experimenting with, but for practical purposes, a 10-to-1 drive is okay. And I'm talking about manual tuning at the moment. You can do clever things with you know, fine steps and stepper motors, but that is really for the second phase of improvement that you may do once you've got it going. And the thing about this torque is it's getting going. It has a very low radiation resistance in the order of milliohms. And so any loop losses impact on efficiency dramatically, and they require careful construction. But you didn't go over the top. As long as you do good construction, you can get going. The problem is, the big thing is getting going. Very high voltages occur at the capacitor, several kilovolts, even at low power. So component spacing and ratings are important. The spacing of the vanes on the capacitor and general safety involved in it. Large loop currents also add to the dangers. So you must keep clear of contact with the antenna. I recommend at least a meter or more QRO because there's a strong magnetic field. As with any antenna, think safety. All antennas are dangerous if you touch them at the wrong time. Okay, design rules. How do we do it? Well, the rules of thumb, I've tried to simplify it down. There's a lot of complicated stuff out there. There are papers full of mathematics and all the rest of it, but it boils down to something very simple. And so the loop circumference got to be between lambda over 10 and lambda over 8 at the lowest frequency to operate as a magnetic loop. You can make it circular, square, octagonal, but circular maximizes the capture area, which is therefore best to do. More difficult if you're trying to bend pipes, but I don't even want to solder pipes. So I'm using coax, and we'll come on to that in the next couple of points. And then you can feed it in a number of ways, but the easiest is to feed it with a Faraday loop. And that feed loop has a circumference of the main loop divided by 5 as a rule of thumb. We're talking about rule of thumbs here. Now, to get good efficiency, you want a large skin area of copper. So the recommended diameter of the loop tuning should be greater than 10 millimeter. And I've made some with just 10 millimeter fine bore copper pipe, and they work. But the larger is better. And as large as you can for the practical cost, the weight, and skin area. For copper piping, we normally use 15 millimeters or 22 millimeters, which are standard water pipes in the UK. Note, I'm going to be talking in millimeters and meters. I don't use feet and inches. They're not scientific measurements. And so let's all work from there. But 15 and 22 millimeters are standard. You would probably say a ½ inch and 3/4 of an inch or something. But difficult to bend unless you're good at doing plumbing. And so a way to do it is to get hold of some heliax. Brilliant stuff. It's very bendable and it's reusable. You can unbend it and bend it indifferently. The smallest I use in this loop is LDF 450, which was I had 6 meters of scrap I got from a station being dismantled. Better is LDF 550, which is closer to the 22 mils. And if you're really lucky for lightweight, because after all, once you get into the big LF loops, LDF 550 is still getting pretty heavy. Although some people I know have made it out of 750, which is even bigger and more wonderful. But then you're starting to get problems with support structures. And today's talk is about lightweight, easy to make. RG52U is the waveguide version. That's very lightweight because it has nothing up the middle. So larger effective conductor diameters might be achieved by paralleling conductors or wiring as a cage. I've not tried this, but I have seen some designs where people have actually done it like you would a cage dipole. You have 2 or 3 conductors paralleled to give an apparent larger diameter, but I haven't tried this. But again, it's more copper, more size, and you know, single band fixed installations that might work for. But another way of doing it and reducing the size, and this is what you're going to see, is a multi-turn loop, and this can be used to reduce the physical loop diameter. After all, we're talking about calculating from our circumference, i.e. the length of the cable, the length of the LDF 450 that is used. And if you wind it as a number of turns, you're in fact moving towards a solenoid. And that is great for reducing the diameter and the value of the tuning capacitor. You're increasing the inductance, and especially at the lower bands. But if you exceed 4 turns, the inductive loss increases significantly, and the optimum is about 2 turns. I've tried 3 turns and got a resonance going down at top band, but and that was on a 3 meter diameter 3-turn loop. But for practical purposes, 2 turns is straightforward to do. So one of the things, if you do multi-turn loops, is to have a view of the spacing of the turns. And this is at least 5 conductor diameters, i.e. the outside diameter 5 times to the next one. Otherwise, you'll get interturn capacitance and it will mess up your ability to tune. Okay, that's rules of thumb 1. Rules of thumb 2. Well, what should you use to tune it? To reduce the resistive contact losses in a tuning capacitor, it's absolutely essential to use either a split stator, where actually no current is flowing across that spring contact onto the center section, a butterfly capacitor, or a vacuum variable. Now, a butterfly capacitor, again, you're going to have to divide your reduction gear by 4 in its effect, and is much fussier on its tuning. A vacuum variable is very expensive, and it goes end to end, and it has its own set of problems. But sometimes you have to use that for really high power stuff, and when you're using servo control, and there's a whole complete topic on that. So I'm looking at a split stator because they're fairly reasonable to come by. Jackson capacitors and a number of others are easily obtainable, and stuff from really ancient kit that appears on boot sales. The plate spacing should be sufficient to handle the voltages. So for up to 30 watts, a 4 kilovolt rating in the capacitor is good, and about a 1.6 mil spacing is typical. You can get around this by using in the split stator, and the one I use is actually only got a 2 kilovolt rating, but use a split stator. The capacitors are in series, and so it gives me a higher capability. Now, make all connections using large diameter wire. I used either copper strap or a flex weave, a short length of flex weave from the loop to the capacitor, and do good soldering. You'll probably need to solder onto the outside of the heliax a good iron. I used a 200 watt iron to do it. It does need it, and to do it quickly and get a good joint. Now, for manual tuning, as I mentioned, a reduction drive 10-to-1 is recommended or more, and another key thing is a non-metallic mast to mount the loop and an insulated box to put the capacitor in. The latter for obvious reasons, but again, if you put a metallic mast up through a solenoid, you're going to ruin it in terms of its magnetic capability. Okay, what formulas do we need? Well, I'm not great in mathematical. When I did my degree, I used to faint at the sight of an integral sign. And so I use simple formulas that are practical and work. So to calculate the loose circumference for lambda over 10, it's 30 divided by f in meters. Quite simple. To calculate the start point inductance of the loop, and we'll come to that later because I will show a chart of the effects of this. This is the formula for a solenoid, and where the inductance in microhenries, radius in centimeters, number of turns, which we're using as 2, and the length of the coil, which in this case is 5 diameters of the coax. And the resonating capacitor, C is 1 over 2 pi f squares times L. All nice, simple, basic amateur radio license passing stuff. No clever stuff needed. Never mind the calculators, stick it in that and it'll work, but you can use online calculators if you wish, but they take into account lots of other things, which are not are a little bit meaningless unless you are really optimizing to the nth degree, and we're sort of knocking it up out the junk box here. So we want to get started. So do this calculation for the lowest and highest frequencies to be used, and that will identify your capacitor range. You may have to add a series or parallel high voltage capacitors to achieve the range you want to cover. And we'll see how I do that in a minute. And importantly, when you wire it into the box, be aware that a stray capacitance can add between 2 and 15 puffs to the capacitance. So you have to take account for that. You have to get a big value split stator. And remember, if you go 600 plus 600, in series, it's only going to be 300. And that's barely enough to go down to 80. I have to pad that. If you can get it even bigger, I could have bought a bigger one, but I didn't have a bigger box at the time. But it will work, as we will see. Okay, I'm not going to dwell on this, but there are, it's in the slide pack. But some technical information resources, some useful classic calculators are the aa5tb.com site, where he's got a calculator. There's 66pacific.com have an interesting site, and also 66pacific.com's got a coil inductance calculator as well, but just use the basic formulas, it'll get you there. And I've put some essential online reading. There's oodles on the news groups, on YouTube, and I obviously came to this talk via magloops.io. There's lots of quite useful stuff there. And there are a few gurus who appear on that one. The kkk5jy.net, Magloop, is a very good site to read. It's a very, very interesting site. And Non-Stop Systems, go there. There's some of the must-read texts there. So there's a range there. ARL Antenna Book's got useful things. A very interesting chapter in International Antenna Collection by Dr. George Brown, from page 229. There's loads and loads more. I could fill a book full, but some of these other online sites will have lots and lots of references, and you can Google it and search the net, varying your search parameters. Okay, we're coming to a bit more interesting bit now. That's the talky bit. This is the doing bit. So now, what's the circuit? What's the circuit? We must have a circuit. So here's the circuit, multi-button switching circuit for QRP. Say QRP up to 30, it's not strictly QRP because I've run it up to 30 watts with nothing flashing over. Okay, so the loop comes in at connection A and B. We have our split stator capacitor, 600 plus 600 at 2 kV per section, so that gives us 4 kV across the end to end. And then I have a big toggle slide switch with an insulated toggle, though you don't switch it when you're transmitting. And I can either switch a series capacitor to reduce it for the higher bands, which you'll need to do to get above 40 meters, to get up to 20 meters, and it helps on 10. And the other way, it puts a parallel capacitor in, and these are stud capacitors, 3.5 kilovolt rated transmitting stud capacitors, and it's as simple as that. Looks easy. Getting it in the box is a bit more difficult, but you'll see from the photographs, and everybody can adapt it to suit their own way. Okay, next one. How did we work out what we wanted to do for the bands? Well, this is a spreadsheet, and I said earlier we calculate the minimum and maximum. Now I did the loop and I measured it. From the calculations, it came to 5.95 or 5 point something or other, and I measured it, and it was very, very close to where the calculation did, and that is therefore 5.885 microhenries for LDF 450 wound at 2 turns of 60 mil spacing and a loop diameter of 800 millimeters. Pretty small. It had to be that because I only had 5 meters to turn to make the loop out of, and a spare 1 meter to make the which is 1/5 of the length. Very conveniently, I had a 6 meter length to make the feed loop. And then the this on the spreadsheet, the capacitor goes from about 15 to 296 measured on the bench, puffs in split stator mode, and then allowing a bit for, I've allowed a bit for strays, and so we have a range of 27 to 300 puffs. So here we are, basically parallel capacitor, CV plus CP, put it in the spreadsheet, and this spreadsheet calculates for different values of standard stud capacitor, the CV plus CP, quite simple, minimum, and CP plus CP maximum, i.e. The 27 plus whatever the CP there is, and therefore if you you calculate the maximum and minimum frequencies for each possible capacitor, and this gives you the range, the tuning range of your main variable capacitor. This is, you know, this frequency calculated from the resonant frequency formula we saw earlier, and the chart comes out. We'll look at this first, and it gives you the ranges. So here I've selected in the green the most useful thing, covers 80, 60, and 40 by having a 56 puff in parallel, and the max and min, which I put in there. And of course, this is a variable input on my spreadsheet, so that I can do what ifs, and I can alter the what ifs on the inductance as well and mess around. And you can see there, I'm running from 7.2 megs, which is just above the UK limit for 40 meters, and down to 3.478. And when measured, it's pretty close to that in real life. So that's quite usable. In the series trimming capacitor, CV times CS over CV plus CS, all basic stuff. We have a higher voltage rating on this because these are series. So everything's in series, and you've got 4K on the, you know, effectively 4K on the split stator. So again, going down the various options, it just so happened that 56 worked out for my particular inductance. This is going to vary up or down a bit, maybe according to your actual loop size or other strays and other things you've got. But in this case, it covers 15.4 down to 9.5. Brilliant for 30 and 20 megs. So there's a 5-band capability switched on a dual loop. Right. You might say, and this again is in the slide pack, you might say, well, you know, what's it going to do with all the covering such a wide range? Efficiency is going to be awful. It's not going to radiate. Well, we'll come to some interesting tests, real live tests we did later. Now, first thing, Max, is everybody following okay? Anybody got any problems so far?
Yeah, Alan, did you want to take any questions that anybody may have?
I'll take questions at the end because I've got a lot of slides, but
okay.
if somebody's really lost, I'll reiterate. Okay, I'll continue. Because I don't want to, unless there's, you know, if somebody's really, really lost or got a really, really killer question, I'll try and answer it in situ, but I don't want to get bogged down in questions until the end, because there's a lot to do. And with Graham's, his bit's very exciting too, because it, let's go down. Right. So,
okay.
What does the hardware look like for all this calculation and sort of worry we've had working out how to put it together? Well, there's the bits to start with. Not going to break the bank. There's my split stator capacitor, standard electrical box with some glands, standard smaller electrical box for the loop, and there's the Faraday loop waiting to go. Some exhaust clamps in stainless steel, nuts, bolts, and washers. And this is the magic cheapo bit. In Tesco's, they do these nice nylon chopping boards for about £2. And they're great. You know, you can. This one will have that one bolted onto it. This one will have that one bolted onto it. I don't know whether you can see my mouse. but the feed loop goes onto the small one, and the others are for spacing the cables out. I actually changed from this water pipe rod to a fiberglass rod I came in when I'd actually made it, and there's my LDF. Okay, so let's look at the feed loop first, because that's the easiest. So we'll click to the feed loop construction, and it's literally, that was a convenient sized box. The short bit of cable, and somebody's asked me this before, is that some sort of tuning stub? No, it's just a bit of cable joining up to the top because of the size and shape of the box. You could have a different shaped box and put your SO239 socket closer. And so the Faraday loop goes out on the center core all the way around and back on the center core, and at one side, the other side earth connects to the center, to the earth as well. So it's a shielded loop. Then my next picture shows ready for loop assembly. There's my loop. I've got my clamp with the spacer for the LDF to go through, and I've got my reduction drive and an insulated coupler, very important, insulated coupler, and my capacitor, split stated capacitor, ready for wiring. And I've already put short tails on there. Bear in mind, these short tails add to the loop length, so bear that in mind. Okay, next one, another close-up after it's constructed. You can see it comes in here, short connection with flex weave up to this bit here. This one here comes in. We only go on the outside. We don't use the inner of the coax at all. And this goes to my little slide switch, where I've got 2 stud capacitors on tags soldered in, and it switches over in a bit of nasty wiring here. Don't look too closely, but it works. You can see to the right hand side the insulated coupler, very important. Okay, those are the component parts, but what does it look like when it's together? So putting it together, and here we are in the back garden. So you can see I haven't got a huge plot. I've got I can just about get an offset center 80-meter dipole at about 5 meters height. So not exactly super for aerials, but this does work and fits on the patio. On the tripod, a fiberglass center, the board with the capacitor clamped near the bottom, the support clamped at the top. The center bit is movable and rotatable, and you can, and I will come to that later, and the spacers. Now somebody will say, "Ooh, that looks a bit grot. It's not parallel." You see all these lovely designs with parallel loops and zigzag bits of copper pipe. Well, that's fine if you're doing copper pipe, but with the Heliax, it's wound as a solenoid, and a solenoid travels. And also from a point of view of fixing it to a pipe clamp on top of the grey box, it tends to offset the, it doesn't look nice and parallel, but it's still electrically doing the business. So now what? Let me just scroll down a bit. Right, here we go. So here's the test setup. Again, on the back patio, I've got a vertical fiberglass whip antenna, end fed, with an anon. It comes back to a switch box, so I can switch instantly between the two. And there's my tripod and the aerial, and I can reach out and tune it. And I've got an FT817 and a small linear, gives me 20 watts-ish, varies from band to band. And my battery pack, my seal lead acid. This is my portable go and sit on a hillside kit. And that's what we did for the test setup. Well, a lot of worry has been, how do we tune it? How do we get this tuned in? Well, the vertical doesn't need tuning in. It's there. And on each band tested, a resonance section was added, albeit I had to unclip one and clip another in, but it did the business. So what's the tuning method? To tune the loop, you switch to the required band on the loop, on the multi-band loop, not doing transmit because it's only a little switch I had, but you could have, even if you had big high power relays, it wouldn't be a good idea. Set the operating frequency on the transceiver. Then the big secret is to tune the capacitor for maximum receive noise. That will get you close. It's not an optimal SWR, but it's actually it's at best resonance, but for the noise and receiving, but it's not quite the same. There's a fractional tweak needed with an SWR meter. So with your SWR meter, tweak for the minimum SWR, and the key thing is adjust the feed loop coupling if needed, and then retweak the tuning. Now the feed loop, I'm just going to go back there. You can see it's not in the plane of the loop. Its angle varies, and as I don't go up and down, that will really get you in a mess. I have it as close to the main loop as possible to couple the signal in, but then I change the coupling by changing the angle of the feed loop. And by changing the angle, you can optimize it for a particular band, or you could set it to compromise to go across all 5 bands. So let's get back to here. I've found that the normal setting on my setup, and this will vary, is a compromise settings between 20 and 30 and 60 degrees from the plane, but very small adjustments are needed. You can get less than 1.3 to 1 on all the bands, but the movement from lowest to highest bands only a few degrees for best match. So you can set it to compromise, and if you have a single band loop, obviously you can set it to an exact match. So do not transmit while making adjustments. Make the adjustments, press the transmitter. On QRP, probably not a problem, but if you had a higher power loop, it's not quite so safe. And I talked about angle of tuning. Well, here we are. There's a close-up of the loop, and you can see that the feed, which just goes down here and behind the white border where the tuning is and out the front, nothing clever. And up the top, you can see the adjustment on the right-hand photograph between 20 meters and 80 meters. And there's my little arrow. Is not very much. It's just moving in a fraction to improve it. So I find I usually set it to the compromise across the bands and leave it there. Let me scroll down this again. Okay, so taking some Rig Expert readings, you can see I could tune that to 3.65 plus or minus 10 kilohertz bandwidth at the 2.6 point approximately. Because again, sorry about the grotty photograph. It was a bright sunny day, and the screen is reflective, and you can see me actually taking the photograph of it in the screen. But you get the point. There's 3.6, 5.3. You can see it broadbanding already, much better. And this is plus or minus 10, so it's about 10 kilohertz wide. At perfection. If you were tuning it for a single band, then that's the sort of bandwidth I've measured. There's a 7.12 normal QRP calling, and again, that's not bad there. What's that? Again, about 10 kilohertz of bandwidth at 2.6 across there. Now, if you put it to a compromise position where this null is higher, and at a compromise I set it to about 1.3, then the bandwidth will broaden. The Q is not optimum, but that's quite a good compromise. Gives you a bit more space. At 80 meters, in the compromised position, you can get 3 channels in on SSB. Okay, and there we go up to 10 megs, and now we're starting to get really usable bandwidth across here. And at 14, you're plus or minus 40 kilohertz. So what's that? 20. You're sort of 35, 36 kilohertz at optimum. So it's quite usable. Now this is all very well, but what sort of measurements did I get in real life? Well, these are the test results, and we'll show you some screenshots again in a minute. You have to operate quickly. You have to do your test when NVIS is dead, because otherwise you can get a false thing. So we were operating on ground wave. Now, why do you want to operate on ground wave? Well, it's all very well when people do tests and they go out via Whisper and say, oh, look, I got through to South America with 0.001 of a watt. Great. 5 minutes later, the propagations change and you won't. For scientific testing, we're trying to have consistency and testing so we can compare our aerials, tweak the ends of the aerials or whatever, and see if we've done an improvement. And so the best way to do that is on ground wave, but outside the near field. So Graham's house is about 8 kilometers away, and I used the 20-watt test carrier, and the bandwidths quoted up there were a 2-to-1 bandwidth, which is actually better than what you saw on those measurements, but it was set at a 1.3-to-1 compromise, which sort of broadened it again. So compared with the signals we were measuring on 80 meters with the whip at minus 87 dBm, and on the loop minus 81 dBm. At 40 meters, I didn't go for the intermediate bands. I can't transmit on 60, and I didn't want to do it on 10. These are the things, but we're sort of going top, middle, and bottom of the range, so it gives an idea. On 40 meters, we measured minus 94 and minus 93, pretty much the same, so close you can't tell the difference. But again, you can see each time you double the frequency, the bandwidth tends to double. And at 20 meters for a single carrier, we were getting minus 96 on the whip and minus 103 dBm on the loop. Because one thing up at 20 meters, you're getting close to the 5 meters long is getting close to a significant part of the wavelength, and you're not fully magnetic. You've got a bit of both going out. It's not optimized. And we tried measuring just for a try 20 meters SSB voice, and we measured that at minus 110, minus 111. Again, okay, we'll see coming up now are some measurements. I'm not going to talk too much about this, how we did the measurements, because this is Graham's part. He's going to thrill you with how the whole club can measure everybody's aerial at a really cheap kit and get good scientific results. But using that, here's the first result. Screenshots from our SDR. We have an SDR that's calibrated and into a reference aerial. And I have here, you can see the black loop is my signal. There's the 80 meter whip. There's the 80 meter loop. Again, bearing in mind, you can say, well, why not use the 80 meter whip instead of the 80 meter loop? Well, there's a lot less noise was coming through the mag loop, and you could point it and turn it for interference or nulling or, and so on. And it does both. A whip tends to do DX, a low angle takeoff, whereas the loop will do both. So that's 80 meters. We then have 40 meters. It was so close, I've only included one here. There it is. So both the signals in both these cases well above the noise floor. And anybody with a reasonable receiver should be able to get that quite okay. Then we've got here 20 meters, the whip and loop were close enough together. I've only showed one because it's difficult to differentiate between. Again, a good chunk above the noise floor. And that's the secret, getting above the noise floor. One of the things that a lot of people nowadays have forgotten, well, not necessarily forgotten, but in small areas, and I can approach where I live, and within half a mile, the background noise level ramps up from about S3-4 up to S7 or S8, and that's due to VDSL, broadband noise, LED lights, and all the other modern electronic rubbish that we have, you know, bad wall bricks for chargers and what have you. So that's there. So the noise floor, and get your noise floor down, use the RF gain, manual RF gain control does help if you're really stuffed. Okay, then 20 meters. 20 meters is not so good above the noise floor. This because again, this is in SSB, but it's perfectly workable, and certainly enough signal that you can stick it into your digital signal processor and recover the signal. Again, the aerial is not as good. I've got it so it covers the area, but once you get above 7 megs, 10 megs, it's really not so good for that. You really need to redesign it to run 20 to 10. Okay, so what sort of signals was I getting in about this time scale? Not on the same day, but I've got a little table here of some contacts I made. From that, running my 20 watts on 80, I got GB100BM up in Crewe in Cheshire at 5.7 both ways. I got a station 100 kilometers south of Berlin about 4 o'clock. That's when 14 megs was probably just starting to go, but it was okay. Again, a perfectly workable signal. You can see he was running about 100 watts or so, and I was running my 20 watts into the loop. And I don't know how efficient the loops are, but probably at its best, about sort of 30% or so. I haven't done any calculations for that, but there's a huge set of arguments as to how efficient it is. It's going to be more than 10%, and it's going to be less than 80% is my guess, and probably about 30 or 40% or so. But I haven't, that's another avenue that takes a whole different set of measurements. And we aren't talking about an optimized system. I got through to a station in the south of France. I got through to about 70 miles on Envis to Surrey up at Coulsdon in London. And on the same contact, I was getting a 5.2 at about 100 miles in the opposite direction in Wales. And on another day, I only took these down at mainly down at 80, which is the most difficult band for it to work. It works best at 40, but at 80, it does work. If you made a bigger loop, then of course you get more down the low end, and those are the sort of results. So certainly worth encouraging and worth working on. So, in case you think it's hard, this is the end of my bit of the talk, but my clip says play the video clip now. Now I'm hoping if I can get back to sharing, can I get back there? How do I get back to this? Let me just minimize this for a second, and let me, I'm ready to go there. Can anybody see on their screens a picture of me sitting at a table? If not, I've got to share that package.
Yeah, not yet.
Pardon?
Not yet. We just still see the slides.
Okay, we got this sharing problem again. Am I going to unshare? How do I unshare it? I know you put me as a you've put me.
So try that. So it's unshared now, Alan.
Okay, unshared. So I'm going to share. Here we go. I'm going to share that one. Now, share. Is that sharing now?
Yes. When you shared, did you click on the two tick marks? There's 2 tick marks. One of them says.
Oh no! Let's do it again.
Okay.
It's working now.
Are you able to unshare, Alan?
How do I unshare it?
I can also.
A minute, let me get. Zoom's gone funny on me.
Do you really want it to?
Okay.
Yeah, so there's Alan. There's 2 tick marks. One of them is share the audio of videos, and so when you're sharing, tick both those.
I've just clicked on. It says advanced sharing options. What is that? All participants, yes. Hang on. Let's get the right. I click share. Right. Okay. It's come up on share. Oh yeah, I see it. Share. and optimize my screen sharing for video clip. And I want to, I've lost there. There we go, there. So let's see if it shares. Are you seeing a picture of me?
Yes, we are.
Okay, let's run it. Is it big enough to view? Or do you want me to go full screen or what?
It's full
It's close
screen
to
on
full
mine.
screen now.
Okay, I'll go full screen. And now I'm going to run. Hello, I'm Alan, G8IPQ. This is my portable setup comprising a Yaesu 817, FT817, a Jago XPA 20HF linear giving 15 to 20 watts, and powered from a lead acid battery into my homemade dual loop. The purpose of this quick demonstration is to show you how straightforward it is to tune up the aerial, and you will have to retune if you move more than a channel up and down from the optimized frequency. At the moment we're tuning to 3.715 in the 80 meter band, the lowest band that this 5-band dual section loop will cope with. Okay, the first action is to reach the tuning knob and tune for maximum noise on the frequency. This will not be tuned exactly on in SWR terms. So the next thing, I will look at the meter on the front of the linear and just tweak the tuning for the lowest SWR, which I hope will be below 1.5. It's reading 1 point, just on 1.5. Tiny tweak. 1.3. Tiny tweak. Very sensitive. Oops, we've gone over. One point two. I think we'll leave it at that point because that's a perfectly workable value. Let me turn the noise down. If you need to get it down to 1-to-1 and closer, you can do it for any single band by altering the coupling a degree or so. It's very sensitive, and you move it just a fraction. At the moment it's set for the compromise for all bands, which means I get between 1.2 and 1.5 right across all 5 bands, but you can set it, do it more accurately. And that is how straightforward it is to tune. If you go up by 1 channel, 2 channels, you can hear the noise drop, and so you can comfortably go up and down a channel and get within 1.5 to 1. 2 channels will be between 1.5 and 2 to 1, and that's still workable for the 80 meter band. As you go up through the bands, you'll get a greater bandwidth before you have to reach in. And that's how straightforward it is. Do make your own and give it a go. Thank you very much. Okay, I've got to unshare this again. I've forgotten how to do it now. Oh wait, let's just close the clip. Did everybody see the clip?
Yes.
Okay, so the next bit I'll share again, and I'll Graham, do you want me to do the slides? And you do the talk?
Yes,
or do
please.
you want...
Yes, Alan, it makes more sense now that you've got it going for you just to
Okay.
carry on.
Okay, let's just get rid of that. So let's share again and go back to, where's the slides? There we go. Share. Okay, can everybody see the slides now?
Yes.
Okay. Now, before I go on to Graham's, this is the point for questions on the first bit. Any questions, anybody?
So, Ellen, there's a couple of questions in the chat. Are you able to see those, or I can read them?
I'm not, since I've shared, my screen's got completely blotted out with the slides.
Okay.
Could
Bruce,
you read it out?
Yeah, or Bruce, did you want to just unmute and ask your question?
Yeah, come on and ask.
You mentioned that the mag loop has a very low radiation resistance. Is one of the purposes of the feed loop to act as an impedance transformer combined with the main loop so that the feed line is 50 ohms?
The feed line that goes up to the feed loop is standard 50. On that test setup, it was just RG58 going down to the transmitter, which was on the table next to it. You can use thicker cable if you want. Although when I did the test in the film, you saw it with just that. Although when we did the tests, I used RG213. It just goes up. It was just attached at the back of the fiberglass, going up through it. It didn't seem to have any dramatic effect, it being there. As long as when it's fixed in position, you leave it in position, you don't move it around near the aerial. So, you know, it's fixed to the mast, and then you can tune out any effects. And I have done it also with a choke, an inline ferrite chokes, and made a little bit of difference, but not much. It may be more critical if you're running higher power, but it's 50 ohm feed line up to the Faraday loop box.
Yeah, I guess that, but if the main loop has a low radiation resistance, are you using the feed loop to provide the impedance transformation?
Sorry, I couldn't quite hear you there. Obviously, my link's not too good. Max, could you just relay that again for me? Hello.
Sorry about that. I got to remember to unmute myself.
Yeah, could you just relay that question a second?
Yeah, actually, I didn't get all of it. It was a pretty technical question. Did you want to try again, Bruce?
Yeah, we're getting a lot of echo.
Yeah, and I think that's from Alan. Alan, do you want to mute yourself?
I got to unshare me again. Sorry.
Okay, no problem.
And I can get back to the controls. I keep losing my controls.
All right, there you go.
Right. Okay. I'll mute.
Okay, go ahead, Bruce.
Okay. Sorry, this is probably too technical anyway, but if I understood you correctly, the mag loop has a low radiation resistance. So to get 50 ohms at the feed line, are you using the feed loop to provide impedance transformation?
And then Alan, just make sure you unmute yourself.
I'm sorry. That's the reason of that the feed loop is 5-to-1. It's a transformer.
Okay.
It's a transformation.
Okay, so your radiation resistance is relatively 10 ohms then?
Radiation resistance will be down in the milliohms.
Okay, but 5-to-1 is enough.
Well, yeah, it's because you're coupling in from a Faraday. It's a magnetic coupling.
Okay.
You're not, because the thing is, you could take away the loop and power the transmitter into the Faraday loop. It would still see 50 ohms.
Okay, thank you.
As long as the length of the loop is right for the band. But it's just using the rule of thumbs will get you started. You maybe have to fine tune it if you've got a particular problem, but it is a transformer with coupling into a resonance circuit. You know, just like a sort of tank circuit. Okay.
Yes, understood. Thank you.
No problem.
And then Dan had a question also. Do you want to just ask your question?
Sure. Or if there's echo problems, perhaps it's easier for you to read it.
All right, Alan. Dan is asking, what about the height above ground? Dale, W4OP of LNR, advocates at least 2 diameters of loop diameter for better results. Have you experimented with this?
If I was mounting it on the house, I would mount it at about 3 to 5 meters above to be full 2 loop diameters. It depends where you define loop diameter. The loop diameter there is only 800 millimeters, although the actual circumference is 5 meters. So the diameter of the loop, it's the coupling to ground. So you've got a solenoid and it is coupling into the ground. So I would suggest, as a rule of thumb, 1 to 2, at least 1, and ideally is 2. But on the tripod I had, I could put a taller pole and stick it up further. It would, if I had stuck it up further, I would therefore have to have a box with a stepper motor and servos, because I couldn't tune it by hand, or a long pole to work the dials. But for sort of sitting on the patio, sitting on the balcony of your apartment, or sort of heaving it out the back of the car, and because that will fold up and go in the back of my estate car, and onto the hillside, it works, and it works at about that height. It may work a bit better higher, but it's only marginal. If you're going to do a fixed loop, then I recommend it perhaps get mounted at least 3 to 5 meters up. They've said above 5 meters, there's no advantage, not for a vertical one. If you tried it horizontally, and you can do those loops horizontally, then you have to mount it at the same height as your dipole, because the horizontal has, you're killing the effect. The advantage with this, you can mount it near ground level, and the rule of thumb is at least 1 diameter. Ideally would be sort of 2 diameters, but most people I've seen making these stick it on a photo tripod or a bigger tripod, and you can see where I was sitting at a table and the height of it, and it was convenient for leaning over and tuning it. If you're doing a single band or an optimized one for your house, then yes, have it a little higher, 2 or 3 meters, and away from obstructions, and you will have to remote control it, either with a motor. One of my next projects is to do I've got a 5 meter aluminium single loop, and I'm going to, I've got a motor and a motor controller, analog that is, so I can tune it remotely because the aluminium is also exposed, you don't want it too close to where you're sitting, then I can control it safely from a little switch box. And if you want to get really clever, you can have your Arduino and controlling servo motors and so on. But you can make it, like any amateur radio, you can make it difficult, expensive, and really good, or you can make it simple, it works, and it's really good. So it's horses for courses. And so to answer your question, it works at least a loop diameter above ground. So put it about a meter and a half above ground is fine, certainly for experimenting. Okay.
Thank you. Thank you.
Big thing is to get started and keep it simple, and then see how you can improve it afterwards. And that means you get excited, and then you go on and do more.
Alan,
any more questions?
Alan, if you look to my right, you'll see a alpha compact loop, and
they work very well. They cost a lot more money than mine.
probably, but mine works.
Over in UK, they'll be about 300 quid, 300 pounds, $300 or $400, whereas mine probably cost me less than $100 to make, and the most expensive part was the capacitor that I shipped in from Holland, from a surplus place in Holland. The rest of it was just bought at the local hardware store. But the Alpha Loop and all those do work very well. Same principle as what I've got, and they're great. As you probably found out, they work very well. But again, I'm trying to get for people who can't afford to buy one or like making things. You know, in this lockdown situation, I've made more aerial bits over the past 3 months in when we had lockdown than I have for the last couple of years. I've made a whole load of kit, and so it's a project you can do on wet winter nights.
Yeah. I live in a 10th floor apartment, so that Alpha Loops works very well for me.
Yeah, well, this thing is similar, and it covers 5 bands.
Yeah, I also use a Yaesu 817.
Yeah, and it works a treat in a small area, and I find that the double loop gives you the ability in the same size to go down to 80.
Yeah.
And I think the Alpha Loop, they give you an extension section to make it bigger, but then it gets a little bit less manageable. Yeah. But you can do it any way you like. People have made wooden frames and they've done all sorts of things. There's 101 different ways to do it, as long as it keeps you busy and lets you have fun. And that's what amateur radio is about.
You bet.
Any more questions?
Ellen, I had one question. As far as using the loop either in a vertical or horizontal orientation, have you tried horizontal orientation?
No.
Or is that recommended?
No.
Okay.
You can if you're on the top of a building, as long as, like any dipole, you know, you've got to get it up at 60 feet for 80 meters. Have you got an aerial that gets you out on 80 that's 1 meter above ground? Quite difficult, and that's the point. You know, you can put it horizontally as long as you're above ground, and you've got to be half a wavelength above ground.
Okay, that makes sense.
Some people have made horizontal loops, but they've got them up in the air, and for practical purposes, you know, there are people in apartments who've done a horizontal one off their balcony, but somebody can try it. But for me, I can't get aerials up at 60 feet above ground. Hence, my normal wire aerial is only at 5 meters or 6 meters above ground, which is mainly Envis, and this gives me low angle radiation off this, and it's less noisy, and I can point it towards noise sources to null them a bit than a vertical. Again, it's something to experiment with. And I know that there are some contest stations who do top band and 80 only, who have large 5 meter diameter dual loops, and they win contests with them. And some people specialize in them. But for something you can get going on a balcony, or you can take out in the car, it's quite handy, and it was just fun to make. But I wouldn't try horizontal.
Okay. Yeah. Thanks, Alan.
Any aerial, horizontal's got to be up in the air.
I have a question. It's, relative to something I saw on the Facebook Magloop page, which is coupling it to a counterpoise of radials to increase the radiation efficiency. Yay or nay?
I can't answer that, but I doubt whether it may help. I haven't tried it, but then again, you'd get better efficiency by increasing the diameter of the tubing. So if I went up from 450 to 550 or 750, I was going to make a top band to 5 meter diameter one, I would go for 750, but it would be very heavy, mechanically heavy. So the first thing is to get the diameter bigger, and the biggest practical is 750, affordable 550, because you can often get surplus when they're offcuts from installations, or when they're renewing stuff from transmitting stations, and they appear in rallies and stuff. Then I would improve the, I like the idea of using LDF because you've got no jointing along the way and you can bend it and you don't have to do pipe bending and all the rest of it. I would then, 2 turns has a better efficiency than 1 turn. The losses are lower. But you've got to improve, instead of using that flex weave, you perhaps use copper strap, and you have to improve your soldering and the layout and all the rest of it. That would improve first. And using counterpoise is you don't use a counterpoise on a loop, really, it's a magnet. You've got to bear in mind that this is a solenoid. If you could transmit at 60 hertz on one of these from an electric motor coil, or whatever it is. It might not be very good, but it's a magnet. And actually, you want to get it away from anything that's going to soak up the magnetic field in the clear. And that's why it's mounted on a fiberglass rod to keep it away from the metal of the tripod. And although some people may have got good results, the answer is try it and measure it. Now, measure it's the key, because in the next part of this talk, there's some ideas for the club to set on their own club-wide measurement system, and you can do experiments and get real results. And Graham's going to talk about that in a minute. But I would say first, improve the quality of the capacitor, improve the quality of the wiring, improve the diameter of the loop before you tried other things. And putting it up at, say, 2 loop diameters is probably optimum for sort of home construction, 2 meters up. And that would be great. My aluminium one's going to go 2 meters up in the garden. And it's unobtrusive. The idea is also to have relatively unobtrusive aerials. Does that help? Any more questions? Does that help? Any other questions? Max?
No, thank you very much, Alan. That was a very informative presentation. That I'd done a little bit of study on magnetic loops, but I had not gotten even into the formula part before I kind of gave up. But now I have something that I can actually refer back to. So thank you very much. And we will post this this video plus the presentation with Alan's permission. So if anybody wanted to go back and refer to some of the formulas or some of the other things that we went over,
okay,
you'll be able to do that.
Okay. Shall we go on to part 2, how we measured it? And I think you'll find that quite exciting. That Graham's got an interesting extra on the back of this that follows on, and I think you'll find it good for general aerial measurement as well as to do with loops.
That sounds good. You'll share the slides for Graham, Alan?
Yes, I will. If you
Okay.
share me again, and I'll get it back.
Absolutely. So I'm not sharing now, so you should be able to share.
Yeah, how can I share that? What am I looking for? Oh yeah, okay, share. I'm gonna have to go to probably slides, share. Are you seeing it?
Yep.
Okay. Graham, would you like to take over for antenna performance measurement?
Yes, thank you. I am here, Golf 3 X-ray Sierra Delta, and well, you've given me something to live up to there. All this exciting business, I hope I can live up to that, but I don't really think so. Okay, so basically, my contribution to this project really originates from the fact that our club, as a couple of separate projects, produced the wherewithal. First of all, we had a club project to build an active receiving loop for people who were living in areas where the background urban noise was considerable. So that was one thing that moved us along the direction that we ended up in. And the other thing was people began to make or claim that they were unable to definitively measure their performance of the homebrew antennas, basically. So we put our heads together and came up with a few ideas. Suffice it to say that the receiving loop was at the front end of our thoughts, but then, of course, the ability to use software-defined radio these days makes a considerable difference to what it costs in order to make some sensible measurements. So anyway, in my section, which is really just an annex to Alan's really, Alan wanted to have some definitive results of his loop, to decide whether he wanted to invest more time in loops or whether he wanted to do something else. And so we invoked the Itchen Valley Radio Club group, who are available for antenna measurement. I happen to be one of those. And we did some tests for him. So basically what I intend to do is briefly describe how we obtained the results for Alan's loop tests and how we set up the SDRs. And then I think I'd just like to mention, discuss anyway, possibly actively, the idea of comparative testing, because as amateurs we don't have access to standards lab equipment every other day. And so consequently we need to get some standards of our own, which are not necessarily of the expensive variety. So that's that. So that's what we're going to do. We're going to talk about how we got the results, talk a bit about the setup of the SDRs, and then talk a little bit about comparative testing and what possibilities might exist there. So, Alan, can we have the first slide? Or the next slide, I should say. Thanks. So basically we have what were thought to be the sort of underlying requirements here. Why do we need to have a low performance, a low noise performance for this? Those noisy urban and residential areas absolutely full these days, at least in this country, of power line Ethernet, ADSL variants, lots of inductive machines, quite a crowded little island we live on, and it's a bit dense population-wise and a bit dense noise-wise. And so basically, if we could measure weaker signals from antennas that perhaps aren't performing as well as they might, then we might be able to come up with some useful results even for those people. So a low noise antenna. The wide band sort of requirement is another thing really. It's quite useful because you have to try to condense the time it takes to take these tests into a short period, because you want the conditions overall to remain essentially the same. Now, Alan did mention that we would be looking to avoid NVIS. That is the case. I mean, what you want is to be able to get a consistent result and be able to compare one thing with another over a short period of time. And what you don't want is variations in skywave return. So how did we deal with that? Well, one way we dealt with it is we are lucky enough to have an ionospheric sounder just a few miles away from us here. And consequently, we're all able, because it's a publicly funded outfit, we're able to look at the current ongoing live values being returned from the sounder. So this means we were able to very quickly determine on any given band, as it covers, it sweeps right through from couple of megahertz, I should say, up to 30 megahertz. We're able to determine when is the right moment to do this, when NVIS is minimized. Yeah, so the flat response would enable us to be able to switch bands and still get sensible results. Once again, of course, we'd have to check what the effect of the ionosphere would be on the next band we move to, but we're able to do that. So that was that. We want a defined gain, or at least a measurable gain, out of the system. So as Alan described, the sensible way would be to try to go for a ground or direct wave, avoiding the skywave return. But obviously we must avoid the near field or the proximity field, because that will give you no useful result for what's happening at a distance with your radiation. So consequently, we chose club members on the membership side who were a sensible distance, more than several wavelengths away. Consequently, in my case, it's about 8 kilometers or 5 miles from between our two QTHs. And so that was that. So that's the logic for that. So if we can now move to the next slide, Alan, please. This is the Itchen Valley Radio Club wideband active loop. We made about 22 or 3 of these, I believe, in a great festival of construction, you might call it. You can just see the loop is about a meter, and it's powered remotely up the coax with a bias T, and it has about 20 dBs of gain. When I say about 20 dBs, it's quite accurate. So if you can switch to the next slide, please, Alan. Here you can see the VNA results. So I'm sure you can appreciate the lower set of curves are S21. There are a number of different loops were measured. You might notice there are a few little anomalies in some of these results. That's simply because some people's construction had a few anomalies as well. However, if you just look at, let's say, the red figures on the screen, I don't know if you can see them, but you can see it's fairly flat in the area of 20 dBs from a megahertz to about 30 megahertz, no trouble at all. And so that was the ideal result there. Okay, next slide, please. This is really just for information. This was the circuit that we arrived at. It was designed within the club, and you can see it's a balanced circuit, and it just indicates there if you wanted to build one, this is what you'd have to do. Next slide, please. Okay, well, when we get down to the software-defined radio, obviously there are plenty of options there to choose from, but we conveniently chose SDR Play devices, in this case the RSP1A, and you can see the results there for that, the kind of expectations in terms of the noise figure just underneath the picture of the device, the noise figure given there is pretty much a very good performance in actual fact. Generally speaking, if your noise figure is less than 16 dBs, it's an extremely good receiver, and so the SDR Play appears to be a good receiver when being used with the various approved pieces of software. I think we'll just move on. Can we, Alan? Can we just move on? Now, obviously, we need to have some confidence in our results, and clearly, you have to have the ability to calibrate these things. We start with a reasonable advantage with the SDR play because it has some, what should we say, inherent calibration. And when it comes to calibrating frequency, it's a bit of an issue in Europe because there are no longer much or many stations that are off-air frequency standards. There's no longer any rugby radio. There's no longer the German equivalent. And so all you can really do to find off-air frequency standards is to rely on your side of the Atlantic. WWV is probably all that's available in that context when it's possible to hear it. And of course, we are at present near the bottom of the sunspot cycle, so it's been a bit problematic if you wanted to get standards above 10 meg anyway. So the alternative, I guess, would be some form of hardware devices, and so we have been forced to look at that. It's probably the case that the best sort of thing you can do these days, certainly on this side of the Atlantic, is to rely on the sat-nav system, and there have been a number of options available. Various commercial devices like Trimble and so on are available for this kind of purpose, deriving their standards from the rubidium oscillators involved in the sat-nav system. But we're lucky enough to have in our club a guy who has been involved in designing these things. G4JNT is one of them, and the picture that you see on your screen is a picture of his design in conjunction with G3RUH. So that's one thing you could do. You get a reasonable standard that way. I mean, it's a bit like, and I can remember going back many years, it's a bit like using the old 100 kilohertz harmonic crystal oscillator as a calibrator. Some rigs used to have them in, and you press the button and adjusted your dial. It's a bit like that, if that's what you want to do, and that's what you're forced to do if you want to operate at reasonably low cost. Yeah. So can we have the next slide, please, Anna? When it comes to the software that we use on our SDRs for this purpose, you've got a couple of options. There's the software which is supplied with the SDR play. It's called SDR Uno. It has some capabilities, as you can see, but there's also HD SDR, and it enables you to do a bit of amplitude. Well, it doesn't allow you to frequency calibrate, though it does allow you to adjust the dial if you've got a standard to hand. But when it comes to measuring signal amplitude, then you can calibrate the S meter on board, which automatically calibrates the dBm and other measurements provided by that bit of kit. So when you have dealt with that, you'll find that you don't have much trouble with the SDR play, because it already has quite a bit of calibration in it. Amplitude wise, you've got built-in calibration with lookup tables and all kinds of things that have been organized. So that's how we rely on the calibration. Nothing fancy, although I must admit on a couple of occasions of having borrowed some upmarket test equipment from my previous academic institution. So we can check it out, and having checked it out, I discover that actually the SDR Play is a pretty accurate piece of kit when used in conjunction with, certainly with HD SDR, which I've used mostly, but also when using SDR, you know. So if we could just step on then one, please. Well, sort of move to the area where I think it's appropriate to discuss what it is you're measuring. We've discussed to a certain extent how I measured Alan and how we do measure within the club any other person's inventive output. But how do you, what do you do for a reference? What is the reference? Well, in the case of Alan provided his own reference. He had his monopole antenna, which was calibrated, and he was able to switch from band to band by changing elements of it. And so his results were able to be compared with that antenna. As you can see, he had some slides which involved one for the loop and one for the monopole. And we were able to compare them directly. But what about other people? Let's say there's someone who A, doesn't have plenty of antennas to compare one against another. Well, our club owns what has been written down on the slide as a spider beam. It isn't. This is actually called a cobweb. Basically, what it actually is 5 dipoles, all stretched in an 8-foot square, and they are open circuit ended. But that has an interesting result, an interesting characteristic. The characteristic is that because the two ends of the dipole in each case, and there are 5 of them, they are on the opposite side to the feed point that you can see as the black box in the picture. On the opposite side to that, you just have a little bit of insulation keeping the two ends apart by a few inches. And so consequently, what you actually have here is a characteristic that's generally understood to be called confined field at the end. And what that does is make it very, very insensitive to objects and ground around it. Consequently, this antenna, which is only, remember, 8 feet square, folds flat. You can get it out, put it up in no time at all, and all you need to do, we have discovered, is to put it on a short pole and strap it to a stepladder, and that's good enough, because this antenna, when tuned on a stepladder and put at 30 feet, shows absolutely no difference in performance. So it's a very convenient device for the idea of measurement. We can lend it out. So let's say someone builds a new type of antenna, wants to know how well it performs. Well, in fact, what we can do is measure it against a dipole on the band that he wants. We simply lend him the multi-band dipole of this type and tell him how to put it up, and then he can transmit alternately on the 2 antennas and get some measurements of how good it works. The cobweb antenna is in fact all full-length dipoles, and it performs that way and has virtually, you know, dipole reference. So the results are DPD. So that's what we have been purporting to do, and it seems to have been fairly successful. Okay, so if we can just step on one, please, Anna. We're talking about comparative results, and you'll remember this slide. This slide Alan had in his presentation, and it shows that he was transmitting on his magnetic loop and then on his voltage mode antenna, the end-fed monopole that you can just see just to the left of the loop. And so that was his case. So he was actually providing both comparative antennas, but we have a system for lending the standard, if you like, measurement antenna against which your results will be compared. Okay, so I think we have virtually exhausted what there is to say, except just to reiterate the two slides, the two comparators. On those slides, I think it was pointed out, but you can clearly see the improved noise performance. Remember that because we're dealing with a receiving loop here and a transmitting loop, we get pretty significant common mode rejection of any noise. And also, as was stated, since we can simply rotate our receiving standard loop, we can rotate it to null any serious problems that might appear. Okay, next one. Well, you may wish to follow this up with an SDR and have a look at it. There are a couple of references in the slide pack here to enable you to get very simple demonstrations of how to calibrate the SDR Play or any other device for that matter using HD SDR. And so that I leave for your future interest. Next slide, please. Okay, that's it. No doubt there might be some questions. If there are, what do you want to know?
Yeah, Pratik had a couple of questions. Did you want to unmute and ask your questions?
Yes, please. Hello, everyone.
Yeah, we can hear you.
Okay, could you please move to slide 34?
Alan, can you do the honors there, please? Okay, that's the circuit of the active receiving loop in the measurement system.
Okay, if you could please explain me that and how things are moving in, because I'm trying to learn the antenna circuits a little bit. So how to approach the circuit
Okay,
design?
well first,
yeah.
Okay, I understand. First of all, it's a dual circuit. So basically, if you draw a line through the middle of the two blocks horizontally, you'll see that you've actually got two channels. Okay, so the two channels then drive into a push-pull output stage, and what's not shown on this diagram is the fact that obviously there is a transformer output involved there, and the slight confusion may be because obviously the power supply has to be fed up through the secondary on the output side there. Is that helpful?
I guess so, but yeah, I need to revisit antenna circuits actually, but it's okay. I'll work it out.
Yeah, the two input channels are each side of the loop.
Okay.
If that's, yeah, okay, got that bit? And
yeah.
And yeah, okay. Thank you.
Okay, I need to learn actually, no problem. So it's
Okay, thanks, Pratik.
Thanks
Any
for
other?
your time.
Yeah,
Yep, that's
absolutely.
fine.
Any other questions for Graham?
Yes. Excuse me. This is N7CQR, and my question was, if you're doing the measurements at 8 kilometers, did you notice a big change when you were changing frequencies? In other words, from, or did you pick just the, a few frequency ranges for your measurement?
Okay, yeah, I understand. I understand what you're implying there is that obviously there's going to be a difference of loss. So, for example, your ground losses for the ground wave are going to increase with frequency, and so you'd expect the signals to get smaller. Yeah, point taken. Interestingly, in Alan's particular case, we were only looking at 3 bands, which was 80, 40, and 20. As it happens, at 8 kilometers, the differences, measured differences between these are relatively small. It does decrease, but only very little. So to put a number on it, I think 20 meters at this range that we have here was only about 1 dB less. Now, I think as the range increased, let's say it was a different member of the club who was seeking to have some measurements done, this could be a different issue. So, for example, at 8 kilometers, it's like that. I think probably we're looking more at direct wave rather than a ground wave per se. But at greater distances, it will, once you're a little bit over the horizon, obviously about 15% over the horizon, you're going to be then relying on a ground wave. And then I think the results would have to be calibrated, or should I say, adjusted to get a comparison. That's why our suggestion is that you have 2 transmitting antennas, 1 receiving antenna, 2 transmitting antennas. So basically, you are comparing the 2 antennas at that range for that particular band. Is that helpful?
Yes. The other question I had, or actually, I guess a comment, I'm assuming that the terrain between the 2 locations was essentially flat.
Yeah, this is a fairly flat part of the world here. Where we are here is in a very large river valley, a very wide one. For example, we're talking about the Solent here, which, as you know, is one of the few rivers in the UK where you can take a couple of 100,000-ton container ship right up to the end of the city, because it's a pretty wide piece of water, and as a result, fairly flat. There's not much. There is a ridge that runs nearby, but when I talk about a ridge, you probably wouldn't recognize it in Oregon. I'm talking about a ridge of about 100 feet.
Yeah, no, we have pretty hilly terrain here. So my question was, if we were going to duplicate this, we'd want to try to locate something of relatively even terrain between the 2 locations.
Yeah, well, actually, when you get a bit further away from our main area of membership, once you're away from that center of gravity, it does start to get a bit bumpy. And the thought was, and we haven't actually done it yet, but the thought was that we could easily make it mobile. The actual receiving station could be mobile because it's all pretty low power stuff. So we're talking about, an SDR receiver. It could easily be done in a car with the receiving loop on a roof rack or something.
Oh, yes. Yeah, that would be helpful. Okay. Yes, that answers the question. Thank you.
Okay, thank you.
Yeah, any other questions for Graham or Alan for that matter? And I do want to thank both Alan and Graham. I know it's getting late on your end of the world, and I really want to thank you for taking the time to speak with us today. I think both topics really, the antenna, the magnetic antenna loop, plus the even just the receiving. A couple of members in our group have been talking about putting up a SDR receiver, not necessarily for antenna testing, but I think that would be very useful. But because a lot of our members do live in a large metropolitan area that, and we have our fair share of solar panels on members' roofs and neighbors' roofs and wallboards and anything and everything you can think of that makes RF noise. And we do have a few members that live outside of that RF noisy area that could easily put up an SDR receiver. But I want to thank you for joining us today, and I really appreciate it.
Yes, thank you, everybody. Glad
And
to
Alan,
go.
make sure you unmute too.
Thanks a lot. We appreciate it.
Can you hear me?
There you go. Yes.
Yes. Okay, I just wanted to finish off by saying, guys, the whole aim of this talk is very much to get you to have a go. Now, it doesn't matter whether it's a loop aerial or you're making your end-fed or whatever, the measurement system, and we use that particular SDR because it's not too expensive. What's it, about £150 or something? It can be done simply with the balance loop and or a reference transmitting aerial, and by using the comparative method. Is my old aerial here any better than my new aerial there from the same location? Doesn't matter on the losses on the same frequency. You can see if you've done an improvement. If I snip a foot off, does that make a difference? You know, and also it's to get you to have a go. Don't be frightened of these things. Don't get sort of lost in all the digital controls and the you know, it's got to be so super low noise and it never works and the theory doesn't say it do it. The thing about amateur radio is having a go, and we discover new ideas and new things. And the whole idea, so all I'm saying to you is do have a go, whether it's at that aerial or something else. We've enjoyed very, very much talking to you. We've done a lot of preparation, and we've put together, and it's very satisfying to share the knowledge and hope somebody will at least can make use of it. And you never know, you might come up with some ideas you want to share with us. So thank you all very much, and very, very best 73s from the Itchen Valley Radio Club and from Graham and myself.
Yeah, thank you, Graham and Alan. And if any of our members do make one of these antennas, I'll be sure that we get some pictures taken to send over to you.
Yes, this is actually quite timely, especially for a group of us that have been building and testing a variety of portable antennas for SOTA and POTA operations, you know, parks on the air. And, you know, we're debating among ourselves the relative efficiencies. So this gives us somewhere to go in terms of testing. So now we just have to put in the work. So this is excellent, at least for some of us. It's really appreciated. And I trust we may be able to contact you if we have further questions.
And Alan, you'll have to unmute yourself.
Yeah, I
about
seem
that.
to have lost my video and controls at the moment. It's all disappeared behind something. Got it back. There we go. What will perhaps be a good idea is once you've shown the video to the full club, you may have a whole tidal wave of questions and other things. Perhaps, Max, you could collate them and send them on with an email, and we'll sort of answer the best we can. And any questions?
Yeah, absolutely.
You okay though with that, Graham? We'll sort of get an answer session together for any questions that come through.
Yes, surely, no problem. 73s, everyone.
Yep, 73s. We're off now. I'm absolutely gagging for some supper.
Thank you both.
So all the best, and I hope everything goes fine in your area, because I know there's all the problems with fires and COVID and all sorts of things going on. So let's hope everybody comes through, and amateur